I'm gonna come back in here into ladders, and let's see, here's my ladder modes, and there's all that text that I threw in there. Let's go ahead and grab that, Control C to copy it, and just dump my cheat sheet right here. Perfect. Alright, we're doing warm-up mode. We've got stabilize mode here. Whoops, I'm not clicking into the comments. There we go. Stabilize mode. Then we have generation and then cooldown. And I need some more networks. So insert network, insert network, insert network. Generation mode. Oops, I'm putting that in the wrong place. Let's just cut that out of there. Paste it into there. Cooldown mode. I think next I have idle mode. And I have one more mode, and I think that's fault mode. Alright, is that right? Yes, it is. Okay, so what are we doing in these modes? The first thing that we're doing in warm-up mode is actually to get into warm-up mode. We're looking for that system start push button to be pushed, and we're going to engage the system sequence start bit for one scan. Easy. So we know we're going to want a trigger, and let's pull that guy in right here. And that trigger is going to need a storage bit, and it looks like I've already got an OS1 in use in this block. That's kind of strange because I just created this block. Well, okay, so there's already a storage bit in it. Okay, I'll take it. I'm not picky as long as nothing else is using it, and as long as it's set up as the right thing. Is that a static? Sure is. Okay, cool. So we've already got that bit. Didn't save us any time though, because I still had to figure out what was going on. Now let's get our system start push button, and when that happens, we're going to need an assignment, and that's going to be our start sequence bit. Okay, so system start push button is going to engage that start sequence bit, and now that I'm thinking about it, when do I want that start button to work? I really only want that to happen when we're in idle, or in idle mode. Actually, idle mode is the only place that I want to be able to access this from. So I'm going to need, first of all, an AND. Let's come over here and drag that in. So I need the system start push button, and I need for us to be in idle mode. So let's grab that idle mode tag. Alright, so when someone pushes the start button while we're in idle mode, then we'll go ahead and engage the start sequence and transition up to there. Let's go ahead and add that into here as well. So I'm going to need, well actually I can just grab that from right here. Start button and idle mode. That's got it. Okay, so I might be going back and forth as these things occur to me and making those changes backwards like that. That's okay. That's all part of the fun. What do we need to do next? Once we're in warm-up mode, we're going to need to bring our PID set point and our PID input in. So that's our baffle PID speed and input. Alright, so let's go ahead and get some moves in here. And we're moving to baffle PID in, and another one for baffle PID set point. And the set point is going to be our warm-up RPM, and our input is going to be RPM. Okay, and we want to set both of those while we're in warm-up mode. So we're going to be looking for warm-up mode to energize each of these. Got it? So what's our next step? After we handle those moves, we need to engage our baffle control. We need to set that, and we need to set our oil pump VFD, and we need to leave those both set as long as we're in warm-up mode. Okay, so we're going to look for set. Bring that down here, and oil pump VFD control bit, and another set. And what was that other thing we were looking for? Baffle control, right. So let's set our baffle control, and same thing, that's going to happen when we're in warm-up mode. And if I wanted to, I could daisy chain some of these things together. So let's play around with that. Let's delete that off of there. And we're going to say, when we move that, we're also going to move that. We are also going to set that. And we're finally going to set that. There we go. So on that one condition, we're going to move the RPM over, move the warm-up over, and we're going to set both of those bits. So that compacted our logic a little bit. That's good housekeeping, but it's a little less readable that way. That's okay. So what else do we need to do? Now we need to set up our PID set point for our oil pump. So our VFD set point is going to be warm-up VFD %. Alright, so I'm going to copy that move, paste it in down here. We're looking for a warm-up VFD %, and we're going to send that to VFD set point. And that's going to be energized by warm-up mode as well. Okay, that was pretty simple. And then we start working on our transition condition to get out of there. So we're going to be triggering the warm-up transition bit. So I'm just going to work this backwards. Let's pull in a trigger. And we're going to give that an OS2 storage bit, local static. And what that's going to do is perform an assignment on our warm-up transition. And we've got a timer on there because we're looking for the oil temp to be at a certain level for a certain time. So let's go ahead and drop that timer in here. And what was the name of those things? Let's see. We're looking for oil temp to be over warm-up oil temp. Alright, so let's pull that comparator in. We need a greater than on the input to this timer. And we're looking for oil temp to be greater than warm-up oil temp. And we're also looking for one more condition. We also want to make sure that we're in warm-up mode. So we're going to need an and drop that in here. Oh, there we go, right there on that timer condition. And let's go ahead and make sure that we're in warm-up mode. Now we need the handling for our time delay set point. So we can go ahead and put that right before here. we know we're going to need a multiply and a move for that. So let's come down here to find our math functions, and let's get that multiply, drop it in, and oh, you know what? I almost forgot. We've got our time, or our convert time block that we've created. So let's just make use of that convert time. So we're going to be doing this while we're in warm-up mode. And what are we going to be translating? We've got a warm-up oil temp delay set point, and we're going to be converting that into, let's call it TI1. We'll define that as local temp time, copy it, and paste it right in there. Okay, so make sure we've got warm-up mode, warm-up mode, warm-up mode is a condition for everything in here except where we're handling the start button, and that we have a condition for idle mode. And just like that, I think we've got our warm-up mode done. Let's move on to stabilize mode. In stabilize mode, oh, this looks a little simpler. Let's work it from the back, and we want to transition from stabilize once we've got our current within the stabilized kilowatt set point range. And you know what, looking at this logic, this is messed up. This should not be the set point. We're not looking for the set point to be within 5 kilowatts of the set point. We're looking for current to be within 5 kilowatts of the set point. So good, that would have caused us some issues if we hadn't caught that. So let's get back over here and let's set up that transition condition. We're going to want a one-shot to start, so our positive trigger. We'll give that its OS3 storage bit. Let's define that as a local static. We're going to need our assignment for stabilize transition. We need a timer before this trigger. And for that timer in, we're looking for a comparator that's going to see if something is within a range. And we're looking for current to be within, and we need a couple of values for measuring what that set point is, the high level and the low level. So I'll go ahead and create an add block right up here. The condition for this add block is going to be stabilize mode. We're going to be looking for stabilize kilowatt set point plus 5. That's going to output to TV temporary value 1. And let's see if it'll let me define that. Thank you. So the plus 5 is going to be our maximum, and then we also need a subtraction function. So let's go ahead and pull in a subtract block, and I'll just attach it to this add. Again, we're looking for our stabilize kilowatt set point, and we're going to be subtracting 5 from that and storing that into temporary value 2. And that, since it's the smaller of the two values, that TV2 is going to be our in-range minimum. Now, coming down here to that timer, we know we need to create a time value. So I'm going to drag my convert time and just dump that into here. And we're going to convert our stabilized delay set point to TI3. That's not what I clicked on. There we go. TI3, define tag, local temp time, and we can put that TI3 here. And then we need one more thing down here. We need a condition that says, hey, we've got to be in stabilized mode, which means we're going to want to bring an AND in here as a condition for the timer. We want things to be in range, and we want to make sure we're in stabilized mode. Okay, so right there we're creating our two set points for the range. We're converting our set point for the delay into a time value, and here we're running that whole thing, the timer, the trigger, and then energizing our stabilized transition for one scan. Nice. You see why I like function blocks? Function blocks are cool. So what else is happening in here? We've got all that timer business, and we've got our creating our set points. The only other thing we need to do is our baffle PID in needs to switch to current, and our baffle PID set point needs to be our stabilized kilowatt set point. That sounds easy enough. So let's come in here and drop down for a move. Let's throw that up top. And when we're in stabilized mode, we want current to be our, not PID, that's going to be baffle. That's going to be our baffle PID in. And then a second move chained onto that one. And we want our stabilized kilowatt set point to be our baffle PID set point. Nice. I think we've got stabilized mode done. Let's move on to generation mode. And generation mode, off the top of my head, I can already remember one thing that we're doing, and that is we're engaging our interlock. So let's go ahead, and I'm just going to do this as an assignment. Well, no, I better not do it as an assignment. I better do it as a set, because if somebody changes languages while the system is running, anywhere I'm not latching my bits, I'm going to run into a problem. So probably my ladder alarms are going to not survive that transition, but that's okay. We'll go ahead and do it the right way from this point forward. I usually hate using latches, but for what we're doing in this project, yeah, I guess it kind of makes sense. So, okay, let's bring that set in here. We've got it, and we are setting our station interlock. So station interlock control is going to be set when we're in generation mode. And remind me, what else was there in generation mode? Oh yeah, the transition out. And that's when someone hits the stop push button. Okay, simple. So we're going to want our trigger. Bring that in here. It's going to need a storage bit. OS4 is the next available one. We'll define that as a local static bool. We're looking for someone to push the system stop push button. And when that happens, we're going to assign our generation transition. Generation mode is done. Moving on to cooldown. Cooldown. I like that. Okay. We're going to reset our baffle PID to the set point of cooldown RPM, and we're going back to RPM mode for that input. Easy. Let's come up here where I was setting that stuff the first time. Didn't I already set that stuff someplace? Yeah, I've got a couple of moves right up here. Let's just copy those, come down here and paste them. Easy. We're looking for ourselves to be in cooldown mode, and we're wanting RPM to be the input, and we want our cooldown RPM to be the set point. Was that what we had? Was it cooldown RPM? Remind me. Yes, it was cooldown RPM. And we should call that cooldown RPM set point, you know. So I'm just going to add an SP at the end of that. Yeah, change it. We changed it here. And now what's that? Why do I have this Oh, that's strange. Maybe I better not change it because it looks like I might have that as something else somewhere else. So, yep, cooldown RPM. Okay, and that's going to set up our PID. So that's done. And what else have we got? Oh, we definitely need to reset our interlock control. That's first and foremost. So let's come up here and get a reset. And yeah, first things first, when we're in cooldown mode, no, we don't want to reset cooldown mode. Let's cut that out. We want to reset our station interlock, not output. Man, click on the right thing, Paul. Station interlock control. There we go. And we want to do that when we're in cooldown mode. Okay, got it. Now it's right. Go back to cooldown mode. What else is happening here? We're transitioning out of cooldown mode after we've had our oil temp down for a certain amount of time below some set point. Easy stuff. Okay, so let's grab our trigger first. And actually, we've got a similar time chain right here. I'm just going to steal it. Let's copy that, come down here and paste it. We're looking for our cooldown transition. We want to make sure we're in cooldown mode. And we copied a timer, which is always a dangerous thing, so we've got to remember to give it its own name and one that generates data for us. Good. We're going to need another OS, so OS5, define tag, local static. We need a new time value. That's going to be TI4. I wonder why we don't have a TI2. That's kind of weird. Alright then. And what are we looking for? Instead of in range, actually we can't change that to a less than, so let's just go ahead and delete that right out of there. And we're looking for oil temp to be below our cooldown oil temp set point. And then we need some time handling. So let's drag our convert time in here. This is going to be true when we're in cooldown mode. And we want our cooldown delay set point to be converted to a time stored at TI4. And let's define that as local temp time. Good. And got it. And just out of curiosity, I want to come up here. We've got a time value here, TI1. We've got a time value here, TI3. And then sure enough, we've got this time value TI4. Well, I think that's weird, so I'm just going to rename that to TI2. I don't want to have like a missing TI2 for no reason. That's just kind of weird. Let's come down into idle mode. And what are we doing? We're resetting our baffle, VFD control, station interlock, and brake control. Oh, sorry, we're setting our brake. E. Okay, that's important. So let's come over here and grab a set. Bring that into idle mode. And we're going to set our brake control. We're going to do that when we're in idle mode. And in the same chain, we're going to reset our oil pump. Let's just start with the most important. We're going to make sure, even though we've already done it, we're going to make sure our station interlock is de-energized. Let's Control C, whoops, let's grab this reset, Control C, paste 2 more of those. And what else do we want to reset? We want to reset our baffle control and our oil pump VFD control. Got it. And was that it? Oil pump VFD, baffle, set the brake, and release the station? Then we have our fault mode, and we're setting a fault mode bit anytime we have any one of our 7 alarms. Alright, so that's not a problem. Let's come over here and take, let's see if we've got an OR. Let's bring that OR over here. And that OR is going to lead to an assignment. And that assignment is going to be energizing fault mode. 3, 4, 5, 6, 7 different conditions to include, oh no, not e-stop, but e-stop alarm. I hate when clicking things doesn't work in here. Escape out of there. Click this one. Okay. We're looking for our brake failure alarm. We're looking for an overcurrent alarm. We'll take an overspeed alarm. We've got a high oil temp alarm. We've got an oil high flow alarm. And we have an oil low flow alarm. Okay, so any one of those is going to engage fault mode. And we still don't have anything that transitions us from any of these other modes into fault mode, but we're going to work that logic out at a later time and date. And that's it for modes. So I think we've got everything in there in our function block.